This is the M7 paper 2. So this is one with calculator. It's from CCEA, and this one's in from June 2023. Let's take a wee look then at question 1. A game costs €22.99. The exchange rate is 1 to £1.10. What is the cost in pounds? So because there's more euros than there are pounds, we're going to need to divide them by 1.1. So our calculation is going to be 22.99 divided by 1.1. And that gives us £20.90. Question 2. Albert wants to buy a gold chain. Gold chains are priced by the length of the chain, and the 18-inch chain costs £264. What will Albert have to pay for a 21-inch chain? So again, a couple of different ways about going with this. So we know 18 is going to be 264. Because I know 18 divides by 3, as does 21, if we divide it through, so if we divide that by 6 and we divide that by 6, divide this by 6 is going to give us 3. 264 divided by 6 gives us 44. So a 3-inch chain would then be 44, and so times that up then by 7. Times by 7, and then we get 308. So to get 21, it would be 308. So our answer to that one then is £308. Again, a couple of different ways of going about that, but that's what we have. Ellie and Tanisha are working out the sum of the angles and polygons. Ellie decides to split the hexagon below into triangles. Show how this can be done. Well, if we go with a triangle there, and then the secret really here is going from the same point, so go from here then to our next vertex, or our next corner, and then our last one here, and so split that into 4 triangles. What's the sum of the angles of a hexagon? So it's 180, 180, 180, 180, and 4 of those then give us 720. Tanisha splits the decagon below into quadrilaterals as shown. What's the sum of the angles in a decagon? Well, if you have 4 quadrilaterals, you have 1, 2, 3, 4. Each quadrilateral then is 360. So we would have 4 times 360. If you do your sums for that, you get 1440. Reflect the triangle in the x-axis. So here's our x-axis here, and this is currently 1 square away. So we're going to go 1 square up. We're going to go then 1 square down. Same for this. There's 1 square. So 1 square here, and then this one's 3 squares away. Do you see 1, 2, 3? So we would then go 1, 2, 3. Our triangle then reflected in the x-axis. A rectangle of length 5 centimeters and width 8 centimeters is enlarged by a scale factor of 4. What are the dimensions of the enlarged rectangle? Well, then that's going to be times by 4, so that's going to be 20. That'll be times by 4 as well, and that gives us 32. Breakfast cereal is sold in 3 different sized boxes. So with 500 grams, 750 grams and 1 kilogram. A new size of box will be made. It will have 20% more cereal than the 500 gram box. It will cost £1.56, which is 20p more than the 500 gram box. Will the customer who normally buys a 500 gram box get a better or worse deal in buying this new size of box? Show all working clearly. So if it is 20% more cereal, then the new packet will be 600 grams. because 20% is quite straightforward for 500 grams. 20% is a fifth, so a fifth of that's obviously 100. So if it's 20% more, then it's going to be 600. It will cost £1.56, which is 20p more. So the cost then is £1.56. Obviously then the 500 gram box is £1.36. And so you can work out a few different things. You work out the cost per 100 grams, I suppose. That would be fine. Or you could work out then the cost, or how much you're getting for 1 pence, whatever way then you want to kind of do it. But if we work out the cost for 100 grams here, so 100 grams for this one, we divide that then by 5. 136 will just work in pence. 27.2 for 100 grams. And then for 100 grams here, I need to divide that then by 6. So 156 divided by 6. And then that's 26p for 100 grams. So it means then the 600 grams one is better. So will the customer who normally buys a 500 gram get a better or worse deal in buying this new one? So they will get a better deal. Visitors to Northern Ireland were asked to name their favourite tourist attraction. The table of probabilities is based on their responses. We have those there. The probability of Mussenden Temple is the same as the probability of Derry City Walls. Complete the table. So if these two things are the same, we need to add these up. So if we add these up, we're going to go for, let me see, 0.3 plus 0.1 plus 0.14 plus 0.2. I think that gives us then 0.74. 1 taking away 0.74 is obviously 0.26, and then 0.26 divided by 2 gives me 0.13. So that one's 0.13 and that one's 0.13. What's the probability of a visitor named? What is the probability of a visitor named Ulster Museum or Titanic? So we'd add those two together, 0.1 and 0.14. That's going to be 0.24. Last week, 1,800 visitors were asked to name their favourite tourist attraction. Estimate how many named the Giant's Causeway. So Giant's Causeway is 0.3. So we would do then 0.3 times 1,800. And that gives then 540. A group of students visit a theme park on a school trip. The graph below shows their journey. They leave school at 9:30 a.m, so that's this wee bit here obviously, and arrive back at 4 p.m. Which was the fastest stage of the journey to the theme park? So there's this bit here and there's this bit here, and it's a steeper one that we're looking for because they're travelling more miles per minute or whatever, or per hour. Because that one's steeper, then it's going to be stage 1. So the answer to that, stage 1. How long did the students stay at the theme park? Well, it looks like they arrived here at 11 and then they left at, looks to be 3:30. So that's going to be then 4.5 hours. Calculate the average speed of the journey back to school. Well, they travelled 20 miles in 30 minutes. So they did, let me see if we get space for this. So 20 miles in 30 minutes. You could either do 20 then divide by half. We're looking for miles per hour, and 30 minutes is obviously half an hour. So if you do 20 divided by half, that'll give you 40. Or else you could just double it up. We know then they travel 20 miles in 30 minutes. So they would travel 40 miles in 60 minutes. That's in an hour obviously. So our speed then is going to be 40 miles per hour. Part A, we have to solve this. So y to the power of 8 divided by y to the power of 2. We subtract their indices here. So we would have y to the power of 6. Solve this inequality. I'm going to take away 3x from both sides. That's going to give me 4x is greater than minus 12. I'm then going to divide by 4. I'm going to x is greater than minus 3. X is greater than minus 3. Rotate the shape 90 degrees anti-clockwise about the point 0, minus 2. So I'm going to get my tracing paper for that, and then work from there. Here's a wee bit I have. This is actually just from the kitchen. So it's rotate the shape anti-clockwise about 0, minus 2. So there's my point 0, minus 2. I have to rotate this shape 90 degrees anti-clockwise. So I'm going to set it on there. Apologies, you can see one from a previous question there, but let's just kind of do this. So we're going to be going from there, and again it's good to set it up in this sort of way here. So I'm going to do my line here. Probably best to use a ruler here if you can, but we want to try an accurate enough shape. From there, and I put my pencil here, and I'm going to rotate this anti-clockwise. So we're going to go this direction here. And I think we're going to end up there. I think that looks like it's landing the line. I think we rotated at 90 degrees. Good to keep your paper. So this paper is now kind of, sort of landscape where it was portrait, and gives you a better idea about how far you've rotated. So there's my point there. So that's going to be the point minus 4, 2, and then minus 6, 1. So minus 4, 2, minus 6, 1, and then just because I know the shape, it's going to end up like that. Let's join this. That's us rotated about the point 0, minus 2. Write the decimal number 19 as a binary number. So remember, a binary then kind of works like this. So it's going to be effectively 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4 will be what we need there. And obviously that is the number 1, that's 2, that's 4, that's 8, that's 16. So we want the 16 in it. 16 and 8 would be too big. 16 and 4 would be too big. So we need a 2 in it, and we need a 1 in it. So that's our answer there. So it's 1, 0, 0, 1, 1. Try to make M the subject of this formula. It says rearrange to make M the subject. So there's a couple of different ways of doing this. The fact that that's a minus 3M, I don't like that. So I'm first of all going to take the M over to this side. So I'm going to add 3M. There are other ways, but I think it generally makes life less hassle if the letter you're trying to get on its own is a positive. So that's going to be H equals 3M plus Y. I'm then going to take away Y from both sides. That gives me H minus Y equals 3M. And now I'm going to divide then by the 3. And I get H minus Y over 3 equals M. Again, it's good to write this out the correct way. So M equals H minus Y all over 3. Question 11. A regular polygon has exterior angles of size 15. How many sides has the polygon? Well, the exterior angles of a regular polygon, any polygon, always add up to 360. So if each one's 15, we simply need to do 360 divided by 15. 360 divided by 15 gives us 24, which means it must be a 24-sided polygon. Bailey thinks all regular polygons are congruent. Is he correct? Circular answer, yes or no. If it's a regular, sorry, I maybe said the wrong thing there. If it's a regular pentagon, they can be different sizes, so the answer then to that one's going to be no. Georgia rolls a dice a number of times and records the outcome each time. She displays her results in this pie chart. So we have this there. Alice thinks George's dice is biased. Bob disagrees. What information is needed to decide who is correct? Well, I guess we need to find out the number of times the dice has been rolled, and check and see then from there. To me, it doesn't look too awful, I have to say. If you've done it like 8 million times, I'm expecting it to be more even. But if you've done it a couple of hundred times, or maybe kind of fewer times than that, then that to me looks about right. So number of trials is what we need to see. Draw the locus of all the points which are the same distance from A and B. So we're trying to find this here, and what you realise early on is we're looking for the perpendicular bisector of A and B. So to do that, we are going to need then our compass. Compasses can tend to be a wee bit fiddly. So we set our compass so it's over half the length between A and B, and we do our arc then like this. That's coming out okay. It's quite light, but hopefully you can see that. Without changing our compass, we then go to the other side, and we then do this and mark these off. Again, you can kind of continue the circle or just work out where they're going to mark each other, across each other. So that's all we need. And if we join up where those two arcs have crossed, that's what we need. So this is the point that are exactly the same distance from A and B. That point there, the same distance from A as it is from B, and so on, and anywhere along that line. So that's the locus that we require. Cuboid B is an enlargement scale factor 3 of cuboid A. The volume of B of X is X. What is the volume of A? Well, A is going to be smaller, and if it's scale factor 3, then the lengths are going to be, if this is, say it have to be 4, then that would be 12 because you times it by 3. But volumes, because it's a volume then and it's scale factor 3, then it's going to be 1 cubed to 3 cubed. So that's actually 1 to 27. So if the big one is B, A is going to be 27 times smaller than that. So it's actually going to be then X over 27. Two similar shapes are shown. We have A, B, C, D and E, F, G, H. Diagrams are not drawn to scale. Find the value of P. Well, this is our key to it here. And because we know both of those, we can then kind of work out any of the length then of these. So to get from 1.6 to 1.2, we would then need to do our 1.2 over. So we're working out what we multiply this by to get this effectively, and we'll do the same then to the 2.8. Now I can see that just happens to be 3/4. Maybe if you can kind of spot that, that's okay. I can see that 1.2 is just 3/4 of 1.6. So if we find 3/4 of that, that'll be fine. But let's do it kind of a more robust calculation. So it's 1.2 over 1.6 multiplied then by 2.8. And if you do that, you'll end up then with 2.1. If you want, you can divide by 4, multiply by 3, divide by 4, multiply by 3. That works as well. But that's going to be 2.1. Find the value of Q. Well, again, look, so we have our 0.75 and we're trying to then get to here. So how do we get then from here to here? Well, again, if this is 3/4 of this one, this is going to be 1. You could divide then by 3 and multiply by 4 to get it to work out. But our value of Q in this case will be 1. When a body is moving through the air resistance R is proportional to the square of the velocity V. At velocity 100, the air resistance is 50 newtons. Find R in terms of V. So we have that R is proportional to the square of the velocity. So that means R equals kV squared. At a velocity of 100, the air resistance is 50. So 50 equals k times 100 squared. So that means k is 50. I've divided then by the 100 squared over 10,000. 50 divided by 10,000 then, which is kind of 1 over 200. So my k then is 1 over 200. Find r in terms of v. We have this here. So then r equals 1 over 200 v squared, or if you want, r equals v squared over 200. Either of those are fine. Find r when v is 120. So r equals v squared over 200. r equals 120 squared over 200. 120 squared, and then divide that by 200. That then is going to give me 72. And that's in newtons just given there. The probability that it rains in Ireland on any given day in December is 0.62. Complete the tree diagram to show this information for Christmas Day and Boxing Day. So it's either going to rain, or if you want, it's going to be dry. Rain, be dry, rain, and dry. And it's then going to be 0.62, 0.62, 0.62. And if you take those away, then you're going to get 0.38, 0.38, 0.38, 0.38. What's the probability that it rains on exactly one of these days? So if it rains on one of these days, it's either going to be here, or it's going to be here. So that's going to be 0.62 times 0.38, or, so we add that on, 0.38 times 0.62. So it's actually the same thing twice, 0.62 times 0.38, so I'm just going to times that by 2. 0.62 times 0.38, we get that, and then times that by 2, get 589 over 1250. 589 over 1250. And if we want that then as a decimal, I guess the question's given this to decimals, 0.4712. And that's us.